All right, the next unit in geometry is on circles. And this is an introduction unit lesson to circles. Today we're going to talk about different terminology related to circles. We're going to talk about arcs and we're going to talk about angles. Okay. Now the first definition is circle. Okay. A circle is a set of all points equidistant from a given point called the center. What that means is this is the center of the circle. Each point on the circle is the same distance away from the center. So a distance from C to O is the same as a distance from B to O. It's the same as the distance from O to A. It's the same as the distance from D to O. And it's the same as the distance from E to O. Okay, so every point on the circle is the same distance away from the center. Okay, that's the definition of a circle. And you name a circle by its center. So this circle is called circle O. So you can either name it like this. You can say circle O like that. You can actually write out the word circle. Or this is the symbol for a circle. And you put the letter of the center, which is O. Okay, those are two ways to write that circle. A few more definitions. A radius is a segment that has one endpoint at the center and one endpoint on the circle. So for example, AO is a radius. AO has one endpoint on the circle and one endpoint at the center. So that's a radius. Another example of a radius would be BO. Another example of a radius would be CO. Okay, so that's a radius. A diameter is a segment that contains the center of a circle and has both endpoints on the circle. It's called a diameter. Okay. Both endpoints have to be on the circle and it has to go through the center. So an example of a diameter would be AB. Okay. Both endpoints are on the circle and it goes through the center, which is O. So an example would be AB. Okay, this next definition is called an arc. An arc is a part of a circle. Let's go with some examples. One example of an arc would be arc AC. Okay, this is an example of an arc. Look at how I'm tracing it. AC, that's an example of an arc. So here's the symbol for an arc. Okay, that's a symbol for an arc. Another example of an arc would be like BC. Okay, BC is an example of an arc. Another example would be arc DE. We're going to talk about arcs more on the next page. That's all for now. This next definition is called a central angle. A central angle is an angle whose vertex is at the center of a circle. So for example, above, angle BOC is an example of a central angle. It's an angle whose vertex is at the center. So an example of a central angle would be angle BOC. Write that down right here. Okay, so this next thing is very important. Okay, we have a central angle right here. So here's what you need to know. The measure of a central angle is is the same as the measure of the arc that it intercepts. So if we look above, let's say for example, angle AOB is the central angle. So what I'm saying is that the measure of angle AOB equals the measure of the arc that it intercepts. This is the arc that it intercepts right here, arc AB. So I'm going to say the measure of angle AOB equals the measure of arc AB. Notice the notation for the arc. So let's just use some numbers, okay? Well, let's pretend that the measure of angle AOB is 50 degrees. That means that the measure of arc AB is also 50 degrees. Okay? Essential angles measure equals the measure of the arc it intercepts. And by the way, in case you don't know this already, all the arcs of a circle add up to 360. So here we go. Let's talk more about arcs. Okay? There's three types of arcs. There's minor arcs, there's major arcs, and there's semicircles. Okay? So minor arcs are always less than 180. Okay? Minor arcs are always less than 180. Now you usually name these with two endpoints, but you could also use more than two letters. Okay? Normally you use two letters, but you could use more. Okay? But normally you use two letters for minor arcs. Okay? But what you have to know is that they are less than 180. I'm going to say that. I'll say that. I'll put that right here. Major arcs are more than 180. I'll say between 180 and 360. So minor arcs are less than 180. Major arcs are between 180 and 360. And you name these with three letters. Okay? You use two endpoints and 1 point in the middle. So just to recap, going back to minor arcs are less than 180. For example, AC. Major arcs are between 180 and 360. For example, DFE. And then semicircles are exactly 180. So for example, JKL, you use three letters for these. Or JML. Okay, so a quick recap. Minor arcs, less than 180. You usually use two letters when you name those, but you don't have to use two. You could use more than two. Major arcs are between 180 and 360. You use three letters for those. And semicircles are exactly 180 degrees. You use three letters for those as well. Example 1. Find the measure of arc BE, CBE, and ACE. All right, so here's what I'm going to do. Let's take it one section at a time. If this central angle is 50 degrees, then it means that this arc is also 50 degrees. If this central angle is 90 degrees, then this angle is also 90 degrees. Okay. Notice how we have a semicircle up top. Okay, we have a semicircle up top. See, let's ignore the bottom part. See how we have a semicircle right there? All those arcs have to add to 180, and all these central angles have to add to 180. So if that's 90 and that's 50, then this missing one has to be 40, so they all add to 180. So that arc's going to be 40, which means this central angle is going to be 40. Continuing right along, notice how we have a semicircle right here. That means they have to add to 180. So if that's 50, this one's going to be 130. Which means the central angle is also 130. Let's do the same thing again. Let's look at this semicircle. These have to add to 180 if that's 130. And this is 50. The other thing you could do is, if you remember back to vertical angles, these are vertical angles, so they're congruent. But now let's answer the question. Find the measure of arc BE. The measure of arc BE equals 50 degrees. Find the measure of arc CBE. That's the first answer. Well, the measure of, notice how I write the answer. I do measure of the arc with the arc symbol. Next, the measure of arc CBE. Well, if you look at a diagram and you trace in this exact order CBE, trace it, you'll see it's 90 plus 50. It equals 140 degrees. And then finally it says find the measure of arc ACE. So go ahead and trace it in order ACE. Add up all of those. So 50 plus 40 plus 90 plus 50. That'll be 230 degrees when you add all those up together. And again, just to refresh your memory from what I said earlier, notice how all the arcs of the circle add up to 360. If you add up all the arcs, they add to 360. All right, here we go. The next example. We have one central angle at 60 degrees. So that means that this arc is also 60 degrees. If we ignore these two, you'll see we have a semicircle, so we add to 180. So if that's 60, this has to be 120. Now, as far as the other two central angles go, we don't have them, but we know that they have to add to 180 because we have a semicircle over here as well, okay? See how we have a semicircle right there? That means they have to add to 180. So 3x plus 5 plus x minus 1 equals 180. Four x minus 4 equals 180. Actually, it should be plus 4. 4x plus 4. Then you subtract the 4, you get 4x equals 176. X equals 44. Yep. So if x is 44, that means this is 44 minus 1 is 43. 3 times 44 plus 5 equals 137. Notice how all the arcs add up to 180, okay? Add up to 360, okay? 137 plus 43 plus 60 plus 120. All the arcs always add up to 360. And now let's answer the questions. The measure of arc LN equals 120. The measure of arc MR equals 43. The measure of arc LR equals 137. Yeah, notice how I'm writing all the answers. And the measure of arc R, L, N. So you have to add some stuff up here. Trace them and go in order. 137 plus 120. So 257. Okay, this next definition is called the circumference. The circumference of a circle is the distance around the circle. The formula is circumference equals pi times diameter, or you can use the formula circumference equals 2 times pi times radius, because 2 times the radius is the diameter. We're not going to do anything else with that today. A few more definitions, though, and then we have a few more examples. Okay? This next definition, circles that lie in the same plane and have the same center are called concentric circles. And now we're going to get to some important theorems and definitions now. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. I'll more on that in a second. This next definition is called an intercepted arc. Consists of endpoints that lie on the sides of the inscribed angle and all points of the circle in between them. So, for example, PQR is an inscribed angle, okay? Angle PQR is an inscribed angle. Because the vertex is on the circle and its sides are chords of the circle. A chord is a segment whose endpoints are on the circle. So PQ is a chord, QR is a chord. And PR is the intercepted arc. We're going to do chords in the next lesson, I believe. Okay. Yes, we talk about chords in the next lesson. Now, what you have to know is that inscribed angles are half the arcs they intercept. Okay, so for example, let's say that angle PQR is 60 degrees. That means that the arc that it intercepts is going to be double that, so it's going to be 120. Okay, central angles equal the arcs they intercept. Inscribed angles are half the arcs they intercept. This goes over what I just talked about, so I won't say anything else about that right now. Find the measure of arc BD. Well, if this is 52 degrees, then that's 52 degrees. Notice how we have a semicircle right here. So it means that those arcs add up to 180. So if we know that ED is 52, then I can say that the measure of arc BD equals 180 minus 52, which is going to be 128 degrees. Find the measure of arc JL. There's a couple ways you could do it, okay? you could use the semicircle again. So if this is 40, then this arc is also 40, which means that the measure of arc JL equals 180 minus 40, is 140. Find the measure of angle PRU. Okay, so PRU is an inscribed angle. So it's half the arc it intercepts. So the measure of angle PRU equals 1/2 of 118. Before I do that, it's 1/2 of PU. It's 1/2 of 118. Just showing you how I'm doing that. So it's 59 degrees. So central angles equal the arcs they intercept. Inscribed angles are half the arcs they intercept. Now let's go the other way. Let's find arc SP. The measure of arc SP equals 2 times the measure of angle PRS. Because it's double the arc it intercepts. I mean, it's double the inscribed angle. So 2 times 27, which is 54. Okay, we're almost done. Three more examples. All right, so first what I'm going to do is I'm going to get the measure of arc HF. HF equals 2 times the inscribed angle. So 2 times 43 is 86. It says FH. Let me redo that. Okay, so measure of arc FH equals 2 times its inscribed angle. So 2 times 43 is 86. Now remember, all the arcs add up to 360. So I'm going to say the measure of arc FG equals 360 minus 204 minus 86. So all the arcs add up to 360, right? That'll give us 70 degrees for arc FG. And we also need the measure of angle FHG. That's an inscribed angle. So it's half its intercepted arc. So the measure of angle FHG equals 1/2 of 70, which is 35 degrees. Okay, last page. Two inscribed angles that intercept the same arc. So if they intercept the same arc, then it means they're going to be half of the same angle. So it means the two angles are going to be half of the same angle, so they're going to be congruent. Look at an example of that in a minute. An angle inscribed in a semicircle. So if it's inscribed in a semicircle, then it's half of a right angle. And then it's half of 180, which is 90, so it means it is a right angle. And the opposite angles of a quadrilateral inscribed in the circle are going to be supplementary, means add up to 180. Okay, so two more examples. Find the value of A. Well, angle WZY is inscribed in a semicircle. That means WZY is a right angle. So I'm going to say 5A plus 20 equals 90 and solve. Since it is inscribed in a semicircle, it means it's half of 180, so that's why it's 90. 5A equals 70, A equals 14. Find the measure of angle EDF. Last example. So if you look at angle EDF, that angle is inscribed in this arc that I'm coloring in red. Angle EGF is also inscribed in the same arc. So since these two angles are inscribed in the same arc, it means the two angles have to be congruent. So it means that angle EDF is congruent to angle EGF. So it means that the measures are equal. Set them equal and solve for x, and then you can find the angle. 2x plus 3 equals 75 minus 2x. 4x equals 72. X equals 18. And now find the measure of angle EDF. 2x plus 3. So 2 times 18 plus 3. 39 degrees. And you can always double check by checking the other angle. 75 minus 2 times x. 75 minus 36 equals 39. All right. That is the end of that lesson. That was an introduction to circles. We did terminology, arcs, and angles.